Well, welcome to our first of 4 videos during our winter break, and hope things are going well for you. Hopefully you're having time to relax and just chill out and whatnot. At the same time, be very, very productive. We had our first grizzly right before break, and we showed many positive signs. Very pleased with the results, but make no bones about it. We got a long ways to go before we get to where we ultimately want to be. So our first problem here today, 2004 Form B. We're in the BC exam here, and so hopefully you've got a parametric problem that looks like this. Probably Bolito's got a different problem in front of him, but anyway, being calculator active, and we talked in one of the videos that this part of the problem right here is called the stem. Anytime they give you an equation in that stem, I want to encourage you to go ahead and plug that into y1 and plug this rascal into y2, just because you know that you're going to be using these two functions repeatedly over and over and over again. And so let's go ahead and get started. This is one of the more straightforward parametrics I've ever seen. There really is no hidden punches on this one, so let's see if we can cruise through it and get our 9 points. The first thing I want to go over here with part A is that the word speed can be worded slightly different. Sometimes what they'll do is they'll just ask us for the magnitude of the velocity vector. That's another way of asking exactly the same question, and we need to be prepared for that. And whenever you see the word magnitude, I want you to think of the word length. So you're picturing a vector in your mind, and we're trying to find the length of that vector. And all we're trying to ultimately do is use the Pythagorean theorem. So what we have is, if you visualize that Pythagorean theorem as if you solved for the c value there, we've got our x prime of t here. Also, a lot of times we'll write it as dx dt. We're going to square that. And then we're going to take our y prime of t, and we're going to square that rascal. And that's all it is for speed formula. We want to evaluate those functions specifically at 0. When I plugged 0 into x prime, all I ended up with was a 3. Even though it is calculator active, this happened to be one of those rare moments where I thought it was actually quicker for me to just plug the 0 into those functions by hand. I ended up with radical 58 for the speed of our particle at t equals 0. Now the other half of this part A is they wanted the acceleration vector. Again, a vector is very similar to an ordered pair, except it's got the sharp brackets on it. And so what we're going to do is we're going to calculate x double prime of t. We also need to calculate y double prime of t. And then let's see, the acceleration vector for us here, evaluated at t equals 0, is simply going to be x double prime of 0, comma y double prime of 0. And here's, this is a 50-50 toss-up, whether you want to take those derivatives by hand. I think we're definitely going to want to put it in the calculator. I think we can make a very strong argument that we're going to eliminate any careless mistakes, hopefully, by doing it on the calculator. Let's see, what did I get? I got 0 for the x double prime of 0, and then I got negative 3 for y double prime of 0. So hopefully you agree with those. Before we get started on B, probably the most important thing back there in the stem was they said at the moment when t equals 0, the particle is positioned at 4, 1. So you've already got your x and your y coordinate that you need to write your equation of your tangent line. The only thing we're missing is the slope. And of course, slope is defined as dy dt divided by dx dt. So all we need to do is to evaluate y prime of 0 divided by x prime of 0. And you probably already got those numbers fresh in your mind. I got 7/3, so my tangent line says y minus 1 equals 7/3, quantity x minus 4, and those might be the easiest 2 points you've ever earned on an AP question. Now again, total distance traveled can be worded slightly different on these parametrics. We've got a particle traveling along a curve, so total distance traveled also represents arc length. So just another way of wording the same question. So we're going to say that the length of this parametric curve, or the total distance traveled, is the integral from 0 to 3. And then it's ultimately the speed function here. So we're going to have our x prime of t wrapped up and squared. We're going to have our y prime of t wrapped up and squared. Those functions are not being evaluated at any specific moment. We're just going to throw this into our calculator. Probably the biggest challenge I've seen, if we've screwed this up the past week or so, it's because we seem to be infatuated with the idea of plugging this into the calculator in multiple pieces. I want to strongly encourage you, you've already got these functions stored in y1 and y2. Let's just go Math 9. You've got the updated version of your calculator. You've got good notation. Let's just plug this whole rascal in at once and be done with it. I think there is a smaller chance of making careless mistakes when we do it that way, and we should end up with 45.227 for the total distance traveled. Part D, we're certainly, on typical terms, we're expecting this to be the most challenging, and so here's what we know. We know that at t equals 0, the x-coordinate is a 4, and then they're asking us, well, what is the x-coordinate at the moment when t equals 3? So this one's just screaming first fundamental theorem. We know that if we integrate from t equals 0 until t equals 3, and if we integrate that x prime of t function with respect to time, the first fundamental theorem says that that's equivalent to the position at t equals 3 minus the position at t equals 0. What we're going to do is we're just going to add that x of 0 term over. So, and that's a 4, so we've got 4 plus the integral of the x prime, which is already stored in y1. So here's what's going to happen. We can let the calculator evaluate this definite integral right here. And then we're going to take that value, we'll add it to the 4 we've got sitting here. And hopefully by the time we're all said and done, you can definitively say that the position at t equals 3 is 17.931. So overall, very straightforward parametric problem. Covers a lot of the typical questions that we'll see within that chapter. Just really sound calculator skills. Take enough time to make sure we don't make any careless mistakes.